Let's talk about the unsung hero inside every pump, the impeller. While it might not get much attention, it's absolutely essential to how pumps work, quietly doing its job at the core of every system. The impeller is truly the heart of the system, transforming the raw power from the motor into the energy that moves fluids. Without it, pumps would be nothing more than idle machines, unable to move a single drop. As the impeller spins, its vanes create centrifugal force, pushing liquid outward and through the pipes. This simple yet powerful action is what keeps entire systems running smoothly. No impeller, no flow, no process. But this vital component faces the harshest conditions, operating at high speeds, under intense pressure, and often exposed to aggressive or corrosive fluids. It's a tough job, and the impeller takes the brunt of it. When impellers fail, it's rarely a sudden catastrophe. Instead, it's usually a chain reaction. Small issues like minor cracks, gradual wear, or subtle imbalances slowly add up over time until the damage becomes critical. Even a bit of extra vibration, a change in the type of fluid, or running at the wrong pressure can set off a cascade of problems. These small warning signs are easy to miss, but can lead to major failures if ignored. That's why we're focusing on the top 5 threats to impellers: cavitation, corrosion, erosion, imbalance, and overheating. Each of these can seriously shorten an impeller's life, if not addressed. In this video, we'll show you how to spot these issues early, and most importantly, how to prevent them from causing expensive breakdowns or downtime. Because when it comes to pumps, preventing failure is always better and far cheaper than fixing it after the fact. So, let's dive in and learn how to keep your impeller and your entire system running strong. First up, cavitation, the most notorious impeller killer. It's a phenomenon that can silently wreak havoc on your pump system if not addressed promptly. Cavitation happens when low pressure at the pump inlet causes vapor bubbles to form and then violently collapse on the impeller. This process is not just a minor inconvenience, it can lead to significant damage over time. Each implosion acts like a tiny hammer, hitting the metal and wrecking performance. Over time, these small impacts accumulate, leading to severe degradation of the impeller's surface. You'll hear a rattling, gravel-like noise and see pitted, sponge-like damage on the vanes. These are telltale signs that cavitation is at work, slowly but surely damaging your equipment. Prevent cavitation by ensuring a steady, unrestricted liquid supply. Check suction lines, keep pipes short and straight, and maintain proper NPSHA. Regular maintenance and inspections are key to preventing this destructive process. Don't ignore strange noises. Investigate suction conditions immediately. Early detection can save you from costly repairs and downtime. Cavitation is silent at first, but its damage is loud and costly. By the time you notice the effects, significant harm may have already been done. Get the pressure right at the inlet and you'll keep this villain at bay. Proper calibration and monitoring are essential to maintaining pump health. Simple checks can save your pump. Regular inspections and maintenance routines are your best defense against cavitation, ensuring long-term efficiency and reliability. Next, we delve into the world of corrosion and erosion, two relentless forces that often team up to wreak havoc on machinery. Corrosion is a chemical process where aggressive fluids gradually eat away at the impeller, causing thinning, pitting, or even rust spots to form over time. Erosion, on the other hand, is a mechanical process. Abrasive particles in the fluid act like tiny sandblasters, relentlessly wearing down the impeller's surface. Together, these processes accelerate damage. Corrosive fluids weaken the surface, making it easier for particles to strip away any remaining protection. To prevent this destructive duo, choose the right impeller material for your specific fluid. Use hard alloys for abrasive environments and opt for stainless steel or non-metallic materials when dealing with corrosive substances. Install filters or strainers to keep solids out of the system, reducing the risk of erosion. Regularly monitor fluid chemistry and pH levels to catch any changes early, preventing unexpected damage. The right material choice and maintaining clean fluid are your best defenses against these destructive forces. Don't let these silent destroyers sneak up on you. Stay vigilant and proactive in your maintenance efforts. Now, let's talk vibration, caused by imbalance and misalignment. An unbalanced impeller shakes the pump, wearing out bearings and seals fast. Imbalance often comes from uneven wear or debris stuck in the impeller. Misalignment happens when the pump and motor shafts aren't perfectly lined up, stressing every component. Even tiny misalignments can cause big problems. Prevent issues by dynamically balancing every impeller and using laser alignment tools. Check alignment after the pump heats up. Thermal growth matters. Regular vibration analysis catches problems before they escalate. Precision here means longer pump life. Overheating is a silent killer, often caused by running a pump with little or no flow. Without enough liquid, heat builds up fast, risking steam flashes, ruptures, or seized impellers. Watch for warning signs: discolored paint, high temperatures, or strange noises. Prevention is simple. Never run a pump against a closed valve, and use sensors to shut down the pump if flow drops too low. Make sure bypass lines work for minimum cooling. Operator training is crucial. Know the risks and act fast. Overheating is preventable with the right procedures. Don't let a simple mistake destroy your pump. Most impeller failures are preventable with proactive care. Here's your quick-hit checklist. Monitor suction pressure and NPSHA. Listen for unusual noises. Use the right impeller material. Always balance and align impellers with precision tools. Install sensors for flow, temperature, and vibration. Keep fluids clean with filters. Train operators on best practices. Protect your impeller, and you protect your entire operation. Predict and prevent. Don't just react.